Hey, this is Joe, and today we're going to talk about factor by grouping, particularly how to factor quadratic expressions, equations, and functions. Now, for each of these three formats, the factoring process is exactly the same, so we're going to work specifically with expressions today. And once again, the process we're going to talk about is factor by grouping, or another way you might have heard the process is called the AC method. In order to complete the process, you need to know how to identify A, B, and C from your quadratic expression, equation, or function. You then also need to know how to properly split up the bx term. You also need to know how to factor out the GCF of two sets of grouped terms. So let's refresh identifying the A, B, and C values of a quadratic expression, equation, or function. In each of the following quadratic expressions, the A value is just going to come from the coefficient of the x squared term for each expression. Quickly we see that our A value is 5 in our first expression, 6 in our second expression, 35 in our third, 9 in our fourth, and 42 in our fifth expression. Moving on, let's identify the B values. These are going to be the values of the coefficients found on the x to the 1 power terms of each expression. So in our first expression, b is equal to negative 3. In our second, b is equal to negative 10. In our third, b is equal to 8. And in our fourth and fifth, since there is no x to the 1 power term, b is going to be equal to 0. Finally, identifying our c values is just identifying the one term that has no x associated with it. Or you could think about it as the constant of the expression. So for our first expression, we get c equals negative 2. For our second, we get c equals negative 4. For our third, c is negative 3. For our fourth, c is negative 81. And for our fifth, once again, since there is no constant term, c is equal to 0. I recommend that at the beginning of you working on the problem, you just reorder your expression so that the ax squared term is in the beginning, your bx term is in the middle, and your c term is at the end. So now let's move on to talking about how you split up the bx term. The AC method has you multiply a and c together, find the factors of a and c, and determine which ones add up to b. After finding those factors, you basically rewrite the bx term as the sum of those two factors. So let's work through an example. Suppose we're supposed to factor 5x squared minus 3x minus 2. Here, we know that a is 5, b is negative 3, and c is negative 2. So first we multiply a and c together, which is 5 and negative 2, and when we multiply those, we get negative 10. We also take note of what our b value is, and in this case, b is negative 3. So now we need to find factors of a and c that add up to be b. In other words, we need to find factors of negative 10 that add up to negative 3. So we begin by listing our factors of negative 10. Well, we get negative 1 and 10, but also we get positive 1 and negative 10. Now we think about 2 times what gets us 10? Well, 2 times 5 gets us 10. So to get negative 10, we have factors negative 2 and 5, and positive 2 and negative 5. We continue trying to find factors that multiply together to get negative 10, but 3 and 4 can't multiply by anything to get 10. And then when we try 5, well, we've already listed that, and so we know we're done with our list. Now we check the sum of each of the factors, and we see that positive 2 plus negative 5 is going to equal negative 3. Recall, negative 3 is our b value for this problem. And so we found our pair that adds up to be negative 3, while also multiplying together to equal negative 10. Now that we know that 2 minus 5 is equal to negative 3, we can rewrite negative 3x as positive 2x minus 5x. This is true because 2x minus 5x is equal to negative 3x. So going back to our example, 5x squared minus 3x minus 2, we can now replace negative 3x with negative 5x plus 2x. The order of these terms are not that important, but the reason I put the negative 5x first is because the first term is going to be grouped with 5x squared, and I see that they have the same coefficient. Similarly, this 2x is going to be grouped with the c value, and in this case, they both share the value 2. The rule of thumb to remember is just try to separate these terms and put them in order so that based on their grouping you can factor out a lot. So now within each group we want to identify what the greatest common factor is. For group 1, the 5x squared minus 5x group, I know that I can factor out a 5 But also the highest power of x that they both share is x to the 1 power, so I can factor out 5x. And so my greatest common factor is 5x. For group 2, I can factor out 2. I cannot factor out x because my c term has no x, and so really my greatest common factor is 2. So now we factor the greatest common factor out of each group. Factoring 5x out of the group 1, we're going to be left with x minus 1 inside because 5x times x will get me the 5x squared, and 5x times negative 1 will get me negative 5x. Similarly, we're going to factor 2 out of group 2, and we're going to be left with 2 times the quantity x minus 1. I recommend, after factoring out the greatest common factor of each group, you check that you did it properly by redistributing their values in to see that group 1 is equal to the group 1 from before, and group 2, now factored, is equal to group 2 from before. Now in our current form, we see that within each grouping, x minus 1 is multiplied by something. And so what we can do is bring x minus 1 all the way out to the front. In other words, we're going to factor it out to bring it to the front, and we're going to be left with 5x plus 2 on the inside. And at this point, we got our factored form of our quadratic expression. And I recommend that you use FOIL to check that your factored form multiplies out to be equal to the expression you started with. So let's review the process. First, you multiply a and c together. Then you list out the factor pairs of a times c. You find a factor pair that adds up to b. We then split bx based on that chosen factor pair. Group one of the split bx terms with ax squared and the other with c. We determine the GCF of each of those groupings and factor that GCF out of each, and simply we finish it by factoring out the common binomial from each grouping. So now I hope you have a better understanding of the AC method, and that you also know how to identify the a, b, and c values of a quadratic expression, equation, or function. For more examples of this problem, please follow the video that I'm showing here. And if you still need more examples after watching that video, please check the description of that video because I made examples to parallel what I talk about in it. And finally, thanks for spending some time with me.